Moving on, we will now jump into the installation process and go over some good things to consider when installing a edge panel. The first thing we always like to cover is what's called a site survey. And the purpose of the site survey is to make sure that you, the installer, is prepared for your install. To make sure that you have the correct equipment, to make sure that you know where that equipment can go and the expectations on range, as well as making sure to meet the expectations of your customer, helping them understand how a security system works, as well as understanding the best option for equipment placement. One of the first things to consider when conducting a proper site survey is cell coverage. With the 2GIG Edge having a cell card built in, cell coverage plays a much bigger part on the site survey. You want to check on Alarm.com's mobile tech app or their website to verify coverage for your panel. Also, you still want to verify equipment needs. This is a great opportunity to do one last check for customer needs and make sure any vulnerable locations are protected, as well as providing if there are any locations that the customer specifically wants protected or additional needs that they have concerns for. The next step, after you've determined which cell provider to bring along with you, is deciding on placement of equipment. And the first frequency we'd like to take a look at is our 345 MHz devices. This is important because these are going to be all of your doors, motions, glass breaks, smokes, COs, and so on. And these play an important factor to the whole ecosystem and security of the home. One thing to keep in mind with our 345 sensors is that they have an open air line of sight range of 350 feet and beyond. But as we transmit through walls, doors, and different building materials, we're aware that that range can drop down. So we rate the real world range as 100 to 150 feet. Also, you want to make sure you avoid placing the sensors in areas where they can be exposed to environmental factors, such as direct sunlight if possible. The other thing to factor in is that if the sensors are going to be out of range of where you're going to place your panel, is we do also offer that 2GIG repeater. And that repeater repeats not only our 345 legacy, but also our E-series or encrypted sensors, along with the Honeywell 5800 series. And the great thing about this repeater is it is a plug-and-play device. So you don't have to program it into the panel, but you can if you'd like to be able to see things like low batteries from the repeater or AC loss or tamper conditions. The next process in doing a proper site survey is to consider the Alarm.com image sensor, which operates off of the 900 MHz band. The image sensor, once again, as a reminder, is a motion detector which takes a snapshot photo whenever it sees motion and sends that off to the end user. The range of these devices is generally 75 to 150 feet from the panel indoors. Open air line of sight is rated for 400 feet. You do need to add in the XCVR3 for the panel to be able to see the Alarm.com image sensors. Keep in mind that these do not have any range extenders or are not compatible with any of the 2GIG range extenders. You can program up to 10 image sensors into the Edge panel. The next thing to consider as far as frequencies and placement of equipment is the Z-Wave band, or the 908.42 MHz device. The Z-Wave band in the Edge panel is a 700 series Z-Wave chip. So the upside to that is you do get an indoor range of 100 to 150 feet from the panel for your Z-Wave devices. Older legacy Z-Wave devices of 500 series are going to be a range of 50 to 75 feet indoors. One of the perks of Z-Wave, however, is that you can utilize an AC powered device to work as a repeater to communicate to out-of-range devices. And Z-Wave is compatible with lights, locks, thermostats, and garage door controllers. Any other third-party devices may see limited or no functionality. The 2GIG Edge panel, however, is backwards compatible with previous Z-Wave versions. The next frequency to consider after placing your Z-Wave devices is going to be Wi-Fi. Wi-Fi plays a much bigger part in the 2GIG Edge system, as we have both the 2.4 and 5 GHz bands. You have devices like the 2GIG Edge, the remote keypads, Alarm.com cameras and Alarm.com doorbells, as well as the OnVIF cameras that all leverage and utilize Wi-Fi, therefore making Wi-Fi a bigger part of the 2 GHz edge system. Now there are several things you need to consider when utilizing Wi-Fi devices. First, you want to make sure that each device has a strong Wi-Fi signal at each location. So it should be a strong, stable signal for each of those devices. And there are several ways you can determine this. You can use the customer's Wi-Fi, or you can use the panel's access point. And the 2 GHz edge access point hosts up to 8 devices. Okay, so you can connect up to 8 devices to the 2 GHz edge access point. Now there are several ways that you can determine whether the signal is strong. And the most reliable one that we have found has been network analyzer apps. And there's several out there, several ways you can utilize these. And these are just a couple examples on quick Google search that we found. Things like Network Analyzer, Wi-Fi Analyzer, or NetSpot. Okay? And just to give you an idea of some of the things that are key features that you want to see in a Network Analyzer tool are things like being able to see the different bands of 2.4 and 5. You also want to be able to see the different channels that the devices are operating on. Also, it's important to be able to see the SSIDs, or network names. And one that's really important is being able to see the signal level. Signal level is crucial because that's what truly tells you how good your connection is to your devices. And the way it works is the closer the number is to 0, the stronger the signal is. So a -30 is good, while a -80 would be very basic. Also, being able to see the security type is a good feature to be able to see. Now there are some other tools that are also usable that you want to be able to see, things like a LAN scan, or be able to view just the upload and download speeds of the Wi-Fi signal. Also being able to see the different channels individually, where you see only the 2.4 gigahertz frequencies and the 5 gigahertz. And then of course being able to see a channel graph is always helpful. So for example, seeing a channel graph like you see here helps me understand which devices are operating on that same channel on that band of network, and therefore what devices may be having problems and become overloaded. Okay? So when devices are all on the same channel and the same band, you'll start to see slower connection speeds, you'll see jitter on audio quality and things of that nature. So it's important to be able to see your different channels that your devices are connected on. Now a couple other things to keep in mind is that we do recommend at least a -67 decibels for devices that are connected to Wi-Fi or better. You can always of course leverage Wi-Fi extenders, as well as changing the channels of different devices to help improve the network connection. Also, there's the newer mesh router systems that may be an appropriate solution. Keep in mind also that Alarm.com cameras, for example, require a 0.5 megabytes per second upload speed per camera, and so that also plays an important part. Now the last piece of equipment that you need to consider, and probably the most important one at the very end here, is going to be your panel. Panel placement plays a huge part of your ecosystem and setting up a 2 gig edge. Panel placement plays a huge part because you want to make sure, one, that all your devices are going to be within range of that panel. Also, you want to make sure that if you're going to leverage the onboard glass break detector, that any window you're trying to cover is within 20 feet open air line of sight of the edge panel. Also, you need to factor in that if you need to run an external antenna in the wall, that you need to choose a wall that has that capability, as you may need to add an external antenna for the cell module. The other things to factor in are going to be height of the panel. Mounting the panel at the appropriate height to take advantage of facial recognition will be a lot more important, as well as Bluetooth, making sure that the door that is going to be used for Bluetooth disarming is at least within 30 feet of the door that will be used. Other things to keep in mind with that is to make sure that you don't install the panel below ground level, and make sure that it's not connected to a switch controlled outlet. Now, as we go a little more deeper into the panel here and show you some of the insides, one of the things we always like to point out is that all of our panels will have a bottom screw, but not all will have a top screw. The first run of panels will have had a top screw, so you may see that top screw occasionally, and it's not required for install. If we remove the back plate and take a look at the back half of the panel here, you'll notice that there is a USB port at the top of the panel that's going to be for your firmware updates, as well as updating the slideshow photos. Also, you have your wall tamper switch You also have your SIM card and the IMEI number. The IMEI number can be scanned on the Alarm.com mobile tech app to be able to add in your cell card. Below that, we also have our 2 speakers that are built into the panel, as well as our barrel connector. One of the nice things with the Edge panel that they've added is the barrel connector is no longer a fixed cable like in our previous 2 panels. The barrel connector cable now is a barrel connector for plugging into on the panel, but has 2 wires coming off of it and is not attached to a transformer. So it makes it ideal for using that barrel connector for in-wall wire runs. Below that, we have our terminal block and our piezo sounder. Now the piezo sounder is 85 decibels at 10 feet to meet the UL 985 requirements. We also have our 24-hour backup battery, our third hand to make ease of use during installation, and our external antenna connector. If we take a closer look at the terminal block, I want to point out all the different terminals and what they're used for. The first one you're going to see here is a ground, a common ground. Then you're going to see the auxiliary positive. On older panels, it also may be labeled the DC out positive. One of the things we want to draw your attention to on these 2 terminals is that these are outputs and not inputs, and to not connect power directly to these terminals, as that can cause damage to the panel and void the warranty. So once again, just to repeat, do not connect power to these 2 terminals. These are power outputs, not the inputs. Next, you have a common ground and our external bell outputs. Our output for the external bell output is going to be 6 to 12 volts at 200 milliamps to give you a little extra juice than we had in our previous panels. Then we have our hardwired zones, which can be normally open, normally closed, or an end-of-line resistor. Following that, we have another common ground, and then our barrel connector. The next 2 terminals are our 14-volt DC positive and negative input terminals. This is the 2 terminals where you tie in power for your panel or keypads. Then you have your open collectors 1 and 2, and then a TX and RX, which stand for transmission and receive data lines. Now the TX and RX and the auxiliary positive and ground are all designed to be utilized with the XCBR3. And that's going to be what you use for the Alarm.com image sensor. So that's the point of that device and its use case. Next we have is our 14-volt DC transformer. This is polarity sensitive. It's 14 volts at 1.7 amps or 1700 milliamps. Keep in mind that each panel requires its own separate transformer, as well as each keypad requires its own separate transformer. Next we have is our takeover module, which we spoke of a little bit earlier. We do want to take a closer look at this though and show you some of the terminal blocks and wiring these devices up. Keep in mind that the takeover module is for converting 8 hardwired zones to wireless. It does dry and powered contacts, but only normally closed devices. And keep in mind that this does not do any life-saving or normally open devices. If we open it up, you'll see that there is a common ground, that's where all your grounds and lows can tie to for your zones. Then you also have your 12V for power, where the takeover module will draw power from the existing panel or a separate power supply. Then you've got your zone ports, terminals 1 through 8. So to take you through this a little bit and show you how to wire up a takeover module, since we're talking about wiring, we're going to show you the process in which you need to follow in order to wire and power up your takeover module. One of the things we want to point out is that the power up sequence of a takeover module is crucial, as if it's not powered up in the proper order, all of your zones tied to a takeover module will show low battery when programmed to the panel. So the first thing you want to do here when you have an existing panel such as this is power down the existing panel. So you want to disconnect all your power terminals as well as all of your battery leads. At that point, you can begin to completely wire the takeover module by moving your zone wires over to the takeover module and then tying your ground and 12V over to the auxiliary outputs of the existing panel. These will usually be the same terminals that powered zones share with the panel. So your powered zones and your takeover module will draw power from the same 2 terminals. Following that, you can choose to leave your commons or grounds tied to the existing panel or move them over to the ground on the takeover module and tie it under a wire nut to share all that space. After that comes the most important part, however, and that is going to be the power up sequence. When powering up a takeover module, you want to make sure that you powered up backup battery terminals first to the takeover module. After that, then you can connect your battery leads to the existing panel and power supply last. As long as you follow that exact order, you should have no problem. So just keep in mind, backup battery leads first to the takeover module, power supply and battery leads second. And just to show you also in leveraging this with a 2 gig takeover kit, we're going to show you how to wire that up as well. With the take kit, we would go ahead, the same problem that you have to make sure as before is the power up sequence. So the first thing we're going to go ahead and do is completely power down the existing system and remove all wiring and the existing CAN and system. Once all that wiring has been removed, you can go ahead and install your plastic ABS housing, power supply board, and your takeover module, and also install the optional backup battery. Keep in mind the backup battery is not included. At that point, you can go ahead and begin wiring up your zones. So you'll wire your zones to the takeover module, then wire in your commons and tie them under a wire net to the ground on the takeover module. At that point, you'll tie in powered zones and the takeover module's power to the electronics power supply board. Once those are tied in, comes in the same steps as before, the power up sequence. You want to power up backup battery leads first to the takeover module. At that point, then you can do your battery leads to the charging circuit on the electronics power supply and power supply last. As long as you follow this exact order, you should have no problem.